So today we're going to talk about finding the area of polygons. So the first thing we have here is the area of a parallelogram. Note the formula for the area of a parallelogram is base times height. Well, in order for us to use that formula, we need to know what a base is and what a height is. Bases are sides parallel to each other, and then the height is the perpendicular distance between the two bases. So in this case, here is a pair of bases. Those two sides are parallel. And then we also have another set of bases right here. So parallelograms actually have two pairs of bases. Well, let's look at the top and bottom as our bases to begin with here. So when we look at the top and bottom of our figure, and we consider those to be our bases, our height has to be the perpendicular distance between those two lines, those two bases. So the height could be drawn as such. That's supposed to be a right angle. So it can be inside the figure. It could also be outside. Imagining that one of the bases is extended. We could do it over here as well. So there's actually an infinite number of heights that connect those two parallel lines. So if you look over here, we have an example. In this example, we have a base of 6 centimeters and a height of 3 centimeters. Now, one thing to keep in mind is that opposite sides are congruent in a parallelogram. And we know that the area equals one of the bases times the height. In other words, the two line segments that are perpendicular. So for area, we're going to substitute 6 for our base. We're going to substitute 3 for our height, and we get 18 centimeters squared. And our units will always be squared when we're talking about area, because area is how many squares are inside of a figure. So if you can imagine a bunch of squares inside of this figure, it's how many of those squares. So we're going to move on now to. So you may remember the area of a rectangle as length times width. Well, a rectangle is a type of parallelogram, so it actually has the same formula as a parallelogram, base times height. It's just that our base and our height form a right angle, and they are also the length and width. So this is the length, but it's also a base, and this is the width, and it's also the height. And you can flip your figure over and see the same thing. So this is a base, and this is a height. They form a right angle since this is a rectangle. Now, if we were to flip this on its side, you would notice the base and height would rotate. So you can see in this example that if I rotate my rectangle, the width or height can be vertical and the length or base can be down at the bottom. So really the short side or the long side could be the width / height and vice versa. So anyway, what you do is you take the base times the height or the length times the width to find the area. And you all remember that from elementary school. Let's look at an example. So here is a rectangle, and it has a base of 10 inches, and it has a height of 4 inches. Again, this is our base or length, and this is our height or width. And so our area is base times height, or you can do area equals length times width. It really doesn't matter which one you use. Either way, we end up with 10 times 4, which is 40 inches squared. So next we have a square, and we know that both sides or all 4 sides of a square are congruent. So we're going to call the sides S. And so the area of a square is going to be, instead of base times height, we're going to replace that with S times S, which gives us S squared, or side squared. So that's our formula for the area of a square. And that's the same as base times height. So if we look at our next example here, this is a square, and you can see that all the sides are congruent, and it has 4 right angles. And so the area is side squared. So let's try an example. So here we have a square where the length of one side is 5 inches. So what's the length of every side? 5 inches, right? So our area is side squared. So area equals 5 squared. So the area is 25 inches squared. Next, we have a triangle. And triangles can be a little bit complicated. So let me explain these a little bit. In this example, you're looking at a parallelogram. The parallelogram has a height of h. So this is the height of our parallelogram. But it's a line segment that connects the 2 parallel sides. And that line segment forms a right angle with the 2 parallel sides. So that's your height of your parallelogram. Now, if we split this parallelogram in half, we get 2 triangles. But you can see you still have a height and a base. So your formula for a triangle is half the area of a parallelogram. Its area equals 1/2 times the base times the height. So we often say 1/2 base times height, like this. Or you can also think about it as base times height divided by 2. It's all the same thing. You're multiplying the base and height to get the area of the whole parallelogram, and then dividing by 2 to get the area of the triangle. So let's look at how this works out. In this example, they use the letter A instead of base, so just don't worry about that. Anyway, you can see that there are 2 triangles that are identical, and the formula is area equals 1/2 base times height, where this A should be a base B. Now, I want us to look at these pictures, because sometimes it's kind of hard to find the base and height in triangles, because there's actually 3 pairs of bases and heights in triangles. In all 3 of these types of triangles, you can see how they are cut out of some type of parallelogram. So a right triangle is cut out of a rectangle or a square, if it's a square would be equilateral. This is an acute triangle cut out of a rectangle, and this is an obtuse triangle cut out of a parallelogram. So you can see that triangles are always cut out of, they're always 1/2 of some type of parallelogram. So that's why they're always 1/2 base times height. And the height can be confusing to find sometimes. So let's see how this works out. In the first triangle, the base and height that are forming the right angle are going to be these 2 sides that make our right triangle. In the second triangle, our base and height, the base is going to be one side of our triangle, and then the height is always goes from a base to the opposite point or vertex and forms a right angle. So you can see clearly the height going from the base up to the opposite vertex. With the first triangle, the base drawing a line that's perpendicular to it will take us up straight up the side, and there's our right angle. And then in our last example, we have an obtuse triangle, and here, this is going to be our base, and that's our base. The height is actually right there. You can imagine that bottom line being extended. And that's how you get your right angle. Now, in reality, there's actually 3 pairs of bases and heights for any triangle. Any side of a triangle could be a base. So let's look at that. So again, a base is a side of a triangle, and the height is the perpendicular distance from that side to the opposite point or vertex. So here, this green base and that green height go together. We have a blue base. The side that's blue can be a base. If you extend that out and connect it to the opposite vertice, you'll see the height becomes this dotted line to form the right angle. And then with the red side, again, you have to extend that side out in order to get a line that forms a right angle from the opposite vertex down. So that's the hardest one to see. Let's look at a right triangle. With a right triangle, if the bottom blue is the base, then the side line that's dotted blue here is the height because they form a right angle. If the side that's red, this vertical side is the base, then the bottom is the height, where we have the red dotted line because they form a right angle. And then this green side, if it's the base, then the height is aligned to the point opposite, to the vertex opposite, forming a right angle. And then the easiest one to look at altogether is an acute triangle. So if we're looking at the red side as a base, then we would go to the vertex opposite and draw a line that's perpendicular to it. If we're looking at the green side, the bottom is the base, then we would go up to the point across from it and draw a line straight down that forms a right angle. And if we're looking at the blue side, we look at the point across from it and draw a line that forms a right angle to the blue side. So these can be a little bit tricky, but hopefully this will help you to identify bases and heights in different kinds of triangles. So let's go and do some examples now. So let's say I have the following triangle, and I know that the base is 8 inches and the height is 6 inches. So we're just dealing with the green here. Well, our formula was area is half of a parallelogram, so 1/2 base times height. And our base in this example is 8 inches, and our height in this example is 6 inches. So 1/2 of 8 is 4. 4 times 6 is 24. So the area is 24 inches squared. Let's look at this next example. Try that and see how you do. Area is 1/2 base times height. So where do you see a right angle? That is a right angle. This little blue one here, that's an obtuse angle. That's not a right angle. So what would be our base and height? 8 and 10 form the right angle. So we'd multiply 1/2 times 8 times 10, which is 40 inches squared for the area. So to recap, the area of a parallelogram, a rectangle, and a rhombus are all base times height. The area of a square, however, even though it is base times height, since they're the same, is side squared. And the area of a triangle is half the area of a parallelogram, so it's 1/2 base times height. And keep in mind, the way that we recognize a base and height is that they are perpendicular to each other. So they're going to form right angles with each other. Whether within a figure or outside of a figure, we should see right angles to have a base and a height that go together.